Welcome to Get Your FRQ On. In this tutorial, I'm going to show you how to use factorial, permutations, and combinations on a graphing calculator. So factorial is used a lot in counting the number of ways that something can happen, different selections, and so on. And basically what factorial means is you take the number and you multiply it by all of the integers less than that number, down to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. And in order to get your calculator to do that, I'm just going to do 5, and then I'm going to go to Math. And then over here, the menu that is for probability. The factorial symbol is the exclamation point. That's menu option 4. So if I just type 5 and then I get the exclamation point, that's 120. So 5 factorial is 120. You can check that. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. But there are other ways to count things, specifically if we have to make a number of selections in a sequence. And that would be either a permutation or a combination. And these are going to be found in the same menu. If I go to Math and I go to Probability, P here is for permutations, C here is for combinations, and I'm going to explain the difference after I calculate some values here. So let's do the number of permutations. Let's do a permutation problem. And I have 2 numbers to fill in. And what this first number means, how many total objects are there to select from? In this example, I'm just going to use 8. And then the second number is, of those 8 objects, how many are you going to choose? You don't have to choose all of them. You could choose 1 of them, 3 of them, 5 of them, whatever. Right? We're going to choose groups of 3. Right? So 8 objects, choose 3. And for permutations, there are 336 ways to do this. And I'm going to do the exact same thing, only now I'm going to use combinations. So I'm going to go back to Math, Probability, Combinations is 3 here. And it looks very similar. I'm just going to use 8 and 3 again. And even though I'm using the same numbers, look at how different the results are. So what this is saying is that the number of permutations of 3 objects from 8 is 336, and the number of combinations of 3 objects from 8 is only 56. Now, why are they so different? The difference has to do with the meaning behind permutations and combinations. With permutations, the order in which the 3 objects are selected matters. For example, if I had 8 letters and I wanted to choose 3 of them, and I chose A, B, and C in that order, if we're talking about permutations, that would be different than if I had selected B, A, and then C in that order. Those would be completely different outcomes. With combinations, we don't pay attention to the order. So with combinations, if I had selected A, B, and C, or somebody else had selected B, A, and then C, or C, A, and B, the end result is we all got A, B, and C in some order, and we're not really paying attention to the order. Right? It's kind of like we draw those letters, and then we put them in a bag and mix them up, toss them out, and there's no way to know which one was selected first. So the number of permutations takes into account the order in which the objects were selected, which means there's going to be more possibilities. Combinations doesn't concern itself with order, so as long as you end up with the same objects, it all counts as one thing as opposed to several things. So that number is going to be a lot lower.